Ever pondered over why a ball thrown in the air follows a curved path? It's all about a fascinating physics concept known as projectile motion. Now, what exactly is projectile motion? When an object is thrown or launched into the air and it follows a curved path under the sway of gravity, that's projectile motion. The object in motion is referred to as a projectile, and the path it takes is its trajectory. There are certain key characteristics that define this type of motion. Firstly, it's a two-dimensional motion involving both horizontal and vertical movement simultaneously. Secondly, these two motions are independent of each other. This means the horizontal speed of the object remains constant, while its vertical motion is influenced by gravity. Thirdly, the acceleration of a projectile is always downwards due to gravity, with a magnitude of approximately 9.81 meters per second squared. Finally, the combination of a constant horizontal speed and downward acceleration results in a parabolic trajectory for the projectile. But what are the factors that affect projectile motion? Three main factors play a role here. The initial velocity of the projectile, including both its horizontal and vertical components, is a primary factor determining its trajectory. Then there's the launch angle, the angle at which the projectile is launched relative to the horizontal plane. A higher launch angle results in a higher peak altitude and a longer horizontal range. Lastly, air resistance, a drag force, opposes the motion of a projectile, particularly at higher speeds and lower altitudes. This can slightly alter the projectile's trajectory and reduce its range. Now, where do we see the application of this concept? It's everywhere around us. From the design and operation of various projectile weapons like guns, cannons, ballistas, to sports where throwing, shooting, and kicking accurately to maximize the range of balls, arrows, and javelins are essential. In architecture and design, the principles of projectile motion are used to calculate the trajectory of objects thrown or launched, such as in fireworks displays or construction equipment. Even in engineering and robotics, concepts of projectile motion are employed for designing and controlling systems that involve projectiles like catapults, launch systems, and robotic arms. In sum, the concept of projectile motion is a fundamental principle of physics, the understanding of which not only helps decode the mystery behind the curved path of a thrown ball, but also finds application in a wide range of fields. From sports and weaponry to architecture and robotics, it's everywhere. So the next time you see a ball arching through the air, remember, there's a whole lot of physics at play.